wheel of a bicycle, but it also could be placed into the front of the vehicle as well, such that you could create a two-wheel drive bicycle with power assist in either the front or rear combinations. But the idea was to be able to integrate as many of the components as we could into the modular unit, such that it was easy to be able to plug and play this device and onto any bicycle. So you're able to retrofit existing bicycles with power assist technology. And I just wanted to be able to go over a little bit of the city car again. We are basically looking at a vehicle that's going to be the size of a smart car, so in length, and that when it folds, it's about 40% the length of a smart car, so it ends up being about 60 inches. And the one interesting thing about it is that within the folded configuration, it's still able to do the O-turn and the parallel parking scenarios. And here we have a front ingress vehicle, so we're actually looking at ways to be able to park 3 vehicles into one traditional parking space, nose in. So this allows us to be able to give more access directly to the sidewalk, such that you don't have to worry about opening a door and getting off into street traffic. We're of course working on the Huriko project with a number of other organizations, including Denokin, one of the Basque Region Innovation Laboratories, and Afai Para, which is the investment firm that's providing the opportunity. And we're looking at ways to be able to create a number of different modules which will be defined or built by co-manufacturers in the partnership. And each one of these modules eventually would be assembled in the final location of a deployment city. So we're looking at ways to be able to create a very modular vehicle that can be assembled similar to the way that a computer is assembled by Dell or by HP of some sort, where you just bring the components to possibly a deployment city in Barcelona, and then you create a small assembly factory similar to assembling a hamburger at McDonald's. And of course, these are some more images of the Huriko city car here in Bilbao at the airport, along your underground metro system. And I wanted to dive deeper into some of the prototyping, because I know that this is a design conference, so we wanted to be able to show you some of the ways that we start to explore and build our ideas. So for both the robo-scooter, the green wheel, and the city car, we've created, we utilize rapid prototyping technologies to be able to get our ideas out into the real world. Basically what you see here is a half-scale version of the city car, which allows us to be able to explore our technology in a affordable way, as well as to be able to rapidly get our ideas out into the world. And I'm going to pull up this presentation. This video here. There's a couple of them for the half scale. I'm sorry. So this one actually is the first fold test, and I'm going to have to minimize this. So actually, this shows you the platform of the half scale, where we were able to use extruded aluminum and a number of robotic control solutions that you would be able to find directly online from a place like robotmarketplace.com. And we just use basic components to be able to show the folding capabilities as well as the driving capabilities. In the next video that I'll show, you'll be able to see the O-turn scenarios as well with the full shell. And basically, we want to be able to use both CAD CAM tools in our fabrication facilities to be able to get our ideas out, and then work with our co-manufacturers to eventually develop the industrial solutions.
Skid pad test.
Oh, that was me speaking. Sorry about that. And I'll just look here since you guys are looking here as well. Once again, thank you for your patience. This is basically just showing you the overall strategy for the folding with a quick prototype using MDF. You see that the exoskeleton shell here is basically using a CNC router to be able to get a number of the contours built and then pieced together. And then eventually we use those individual pieces to be able to create aluminum casted molds that we then heliarc together. We'll also look, I think we might have seen the O-turn during that folding process. But this is our laboratory in Boston, in Massachusetts. And we have this vehicle on tour, actually in the US at the moment at a number of different museums. So that is our half-scale prototype. And I think I'm supposed to speak a little bit more about the robot wheel technology. So I'll go back to the presentation and then maybe switch back to videos again if necessary. But here we start to see some of our full-scale prototypes where we're looking at a hub wheel technology as well as a steering integrated into the knuckle of the vehicle. So we're trying to be able to place as many of our functionalities into the wheel itself. So the total combination here, which would then bolt onto a chassis, has braking, steering, suspension, drive, as well as control opportunities that would be built into one unit that can then be interchanged very quickly or very rapidly on a platform, such that in a fleet system, you're able to reduce the amount of downtime for a vehicle, as well as the opportunity to be able to, at a later point, upgrade the vehicle with newer technology or better driving characteristics or performance. So that's part of the modular design. And we eventually build all of our ideas as well at our campus. And here you see the full-scale version, which would be able to allow us to do the O-turn scenario, the traditional drive-in scenario, parallel parking scenario, where you just would be able to slide into a parking spot, as well as four-wheel steering in a traditional drive scenario where you might be able to translate between lanes at high speeds, or be able to do a mirrored steering solution, which would allow for more maneuverability at slower speeds. Here are some of the basic components that you might be able to purchase online, as we had spoken about, to be able to build your own platforms, to be able to get your ideas of electric mobility into the real world. And it's I would say pretty simple, it's pretty straightforward. They give you these enough information online from different blogs to be able to build your own strategies or your own ideas. And I would encourage you to actually to take advantage of some of these opportunities to be able to be a part of the electric world that's coming. I'm just trying to see which of these videos might actually be worth looking at. This particular video here shows you some of our CAD CAM or CAD scenarios where we're using CATIA to be able to look at kinematic models for solutions for swing arm technology with integrated steering. And this technology is actually what we will be using for at least the first prototype of the Herico vehicle. Let me see, I think this is also probably reasonable to watch, if it can pop up.